Alright, so in the last section, we used parallel lines to our advantage. We said, okay, these lines are parallel, so that means all of these things are congruent or all of these things are supplementary. And now what we're going to do is we're going to reverse those, because all of those theorems that we already talked about are biconditionals, meaning the converse is also true. And so before we said if our lines are parallel, then we have congruent corresponding angles. So now we're going to say, well, if the corresponding angles are congruent, if we have congruent corresponding angles, then our lines are parallel. If we have congruent alternate interior angles, then that means we have parallel lines. If we have congruent alternate exterior angles, that means we have parallel lines. And if we have supplementary, same side interior angles, that means we have parallel lines. And so the key thing here is going to be not to assume that they're congruent until you know that they're congruent, and not to assume that they're parallel until you know they're parallel. It's going to be very, very tempting to do one or the other. So very similar to what we did last time, except it's going to be kind of backwards. We're going to say, okay, what value of x makes the lines L and M parallel? Well, so if 2x was equal to 50, then we would have congruent corresponding angles, and then our lines would be parallel. So basically x would have to be 25. Over here, 120 and 2x plus 10, those are same side interior. And we've got this obtuse and we've got the acute one. And so those two would have to be supplementary. So we'd say 120 plus 2x plus 180, 2x plus 10 equals 180. And solve that. So you get your 130, subtract your 130, you get 50, divide by 2, you get 25. And so if you have supplementary same side interior angles, you have parallel lines. Next, these right here, opposite sides of the line, on the inside, alternate interior angles. We want those to be congruent, the obtuse and the obtuse. So we set them equal to each other. Because if they're congruent, then we'll have parallel lines. Alternate interior again. Subtract your 5x, add your 29. And so divide by your 5, you get x equals 8. These are alternate exterior, alternating sides of the line, but on the outside of your parallel lines. Now, I don't know that they're parallel, but if I set them equal to each other, then I would have congruent alternate exterior angles, which would tell me that I have parallel lines. Divide by 4, you get 31. So, is there enough information to prove that we have two sets of parallel lines? Sorry, just one set. So this and this are congruent. Well, and those are corresponding angles, and so yes, there is enough information, because congruent corresponding angles tells me I have parallel lines. Again, the fancy way of saying this would be back here, the corresponding angles converse, right? Corresponding angles converse. You're welcome to say it that way. I like saying it like this because it helps me remember what I need to know in order to prove it. Do we have enough information for this one? This one, they are on alternating sides, but one's on the outside and one's on the inside. This is not a relation that we've talked about. So then you're like, well, it's vertical with this, but if this is congruent to this, we don't necessarily know that these are parallel, just because they're congruent. Now, if they were 90 and 90, then we would know it's parallel, but we only know they're congruent. And so if it's not drawn to scale, we can't make any conclusions. Because they're not corresponding, they're not alternate interior, and they're not alternate exterior. So, let's prove that alternate interior angles converse. meaning if we have congruent alternate interior angles, do we have parallel lines? And we can't use the theorem to prove it, unfortunately. So, but what we can do is we can relate 1 to 3 after we state our givens, right? 1 and 2. We can say 1 and 3 are congruent because they are vertical angles. Vertical angles are congruent, or vertical angles congruence theorem. Next, 3 is related to 2. Sorry. 1 is related to 3 because of vertical angles, and then 3 is related to 2 by a little substitution property of congruence. So you take the 2 and you plug it in place of the 1. We substituted it. And then finally, because 2 is congruent to 3. That's not right. That's not what I was trying to say. Yeah, because 2 is congruent to 3, we have parallel lines because the corresponding angles are congruent. And when you have congruent corresponding angles, you have parallel lines. And this, remember, is the postulate that we didn't need to prove. This is the one that people say, that makes a lot of sense. That's the no-duh type thing. So let's try another. So we've been given that angle 1 is congruent to angle 2, and we've been given that A is parallel to B. So we've got the arrows on the A and B, but we don't know that C is parallel to D. So be careful to say, oh, C is parallel to D, so these must be supplementary. Don't know. And 4 and 2 must be congruent, because we don't know that, because that's what we're trying to prove, that they're the same. So 1 is congruent to 2. We do know that. But let's start with what we know with the A is parallel to B. So let's start with the given there. A is parallel to B, the given. And then right off the bat, what does that being parallel tell me? I added this 4 in here because I'd rather not talk about 1 and 3 being supplementary. I'd rather talk about 1 and 4 being congruent. And they are corresponding angles. If you ignore this extra transversal, those are corresponding angles. They're in the same corner. So 1 is congruent to 4. Because parallel lines tell me corresponding angles are congruent. And then, well, we know 1 is congruent to 2. That was a given. And so because 1 is congruent to 2 and 4 is congruent to 1, we can do a little substitution again. 4 goes in place of the 1. And because 4 is congruent to 2, we have congruent alternate interior angles. And so, because those are true, we must have C being parallel to D. Because we have congruent alternate interior angles, we have parallel lines. And that, my friend, is how you use the converse theorems. Again, when you have the congruent angles, you can prove parallel lines. The biggest mistake that people make is saying, hey, 4 must be congruent to 2. Don't say that unless you've said other stuff before it leading up to 4 being congruent to 2. Don't assume, hey, they're alternate interior angles, they have to be congruent. Because that is only true if they are parallel. Biggest warning I could ever give you. Best of luck as you start proving these things. Great job.